In Lesson 66, we'll be working with square roots. The first part is on simplification of radical expressions, and then we'll also be discussing how to solve square roots for large numbers, how to simplify those. Let's just do some practice problems to understand simplification of radical expressions. Now in Lesson 63, you learned how to simplify radical expressions down to like a whole number factor times a simplified square root, one that you could not just take the square root of and get a whole number result. Then in Lesson 65, we learned how to add radical expressions together, and we know that if we have similar square roots, then we just think of those as like terms and we can add those together. Now basically in this lesson we're going to combine those two concepts together in a problem. And so in practice problem A, what we would want to do first is see if there's anything under the radical sign that we can simplify, and then we'll go ahead and do our addition. If we have some like terms, we'll go ahead and add those together as well. So look at practice problem A and look at the first term, the square root of 18. Think about the square root of 18. Think about a factor of 18 that you could take the square root of. And you could, right? You'd have 9 times 2. So let's just rewrite this as the square root of 9 times the square root of 2. And then plus 3, the square root of 8, that could be broken up into the square root of 4, because we know what the square root of 4 is, times the square root of 2. So we'll do that. And now let's go ahead and further simplify. Take our square roots that we know the square root of and change those into their roots. 3 times the square root of 2, and then plus 3 times 2. Remember, all of this is multiplication. Anytime you have a number in front of a radical sign, that means multiplication. So we have 3 times 2 times the square root of 2. Okay, so now we have two terms that both have a square root of 2 in them. And so that's just like similar variables. We could say 3x plus 6x is 9x. In the same way that 3 times the square root of 2 plus 6 times the square root of 2 is 9 times the square root of 2. And so that's our answer there. So now when we see radical expressions to add together, the first step will be to see if we can simplify each individual radical expression, see if there's any square roots that we know the square root of that we can factor out into whole number factors. Then we'll go ahead and add if we have like terms. Look at practice problem B. First we see that we can simplify some of those radical expressions. So let's look at the square root of 27. Think about a factor of 27 that we know the square root of, and that would be 9, because 9 times 3 is 27. And so let's break this up into the square root of 9 times the square root of 3 minus 6 times the square root of 3. We really can't do anything with that 3 because it's just a prime number. And then 48. Think of a factor of 48 that you know the square root of. And you want to try to think of the largest factor of 48. I mean, 4 times 12 would work, but so would 16 times 3. 16 is the largest factor of 48 that you know the square root of. So go ahead and do square root of 16 times the square root of 3. Now just to think about this for a second, if we would have said 4 times 12, we could have had the square root of 4 times the square root of 12. But you just got to keep thinking. Don't just stop there. Double check yourself and think, well, what is the square root of 12? Is there anything I could break that into? And yes, you could. You could do 4 times 3 because you know the square root of 4. And so you'd have the square root of 4 times the square root of 4 times the square root of 3. So just be careful on those when you have these larger factors that you're trying to figure out square roots for. You always want to find the largest factor that you know the square root of to simplify these radical expressions. So now go back and simplify further. Square root of 9 would just be 3 times the square root of 3 minus 6 times the square root of 3 plus 4 times the square root of 3. Okay, so now we can add all these together because they're all like terms. And we could think of it as 3x minus 6x plus 4x. And so that would be a positive x, or a positive square root of 3. Let's do another one. Look at practice problem C. 3 times the square root of 45 minus 2 times the square root of 24. Well, let's just go ahead and simplify within the radical sign first. Look at that 45. Think of a factor that you know the square root of. Well, that would be a 9, right? Because 9 times 5 is 45. So we'll say 3 times the square root of 9 times the square root of 5. Minus 2 times, well, 24. Think of a factor of 24 that you know the square root of. You have 4 times 6 is 24. 4 would be the largest factor that you know the square root of. So you do 4 times the square root of 6. Okay, now you can simplify this. 3 times the square root of 9, that'd just be 3 times 3, or 9 times the square root of 5. And then minus 2 times the square root of 4, that would just be 2 times 2, or 4, times the square root of 6. Now, we don't have like terms here, right? Because we have different radical expressions. So this is our answer. This is as far as we can take this. We can't simplify it anymore. Now, just to make sure you understand how I got the 9 in front of the square root of 5 there, this square root of 9 cancels to a 3, or changes to a 3, right? Square root of 9 equals 3, and that's why I did 3 times 3 is 9. And then the square root of 4, that is the same thing as 2, right? So I did 2 times 2 is 4. That's how I got the 4 in 4 times the square root of 6. Let's do one more. Simplify 4 times the square root of 50 minus 2 times the square root of 2. Well, the square root of 2, we can't simplify that anymore, but we can simplify the square root of 50. Think of two factors of the square root of 50, one of them that you know the square root of. And that would be a 25, right? 25 times 2 is 50, so we'll say 4 times the square root of 25 times the square root of 2 minus 2 times the square root of 2. And then we can simplify the term on the left. 4 times the square root of 25 is the same thing as 4 times 5, so that would be 20 times the square root of 2 minus 2 times the square root of 2. And we have like terms there. They both have a square root of 2 in them, so that would give us 18 times the square root of 2. So to simplify radical expressions, first see if there's anything you can simplify within the radical sign. Then, after you've done that, see if you have any like terms, add those together. The second part of this lesson is on square roots of large numbers, and let's just start here with the square root of 100. We know that that is equal to 10. Now there's an interesting pattern that develops with these square roots of multiples of 10. And let's look at this one, the square root of 10,000. There's 4 zeros there. If you did that on your calculator, you would see that that is going to equal 100. Then if you did this, the square root of 1,000,000, notice you have 6 zeros in 1,000,000. That equals 1,000. So do you see the pattern here? When you have an even number of zeros under the radical sign, when you move that out, you just end up with half that number of zeros. See, like you had 2 here, 1 here, 4 here, 2 here, 6 here, 3 here. So that pattern is something to try to remember. And if you memorize that and you understand that particular pattern there, when you come up with a problem like this, a square root of 1,000, you do this just like other square root problems where you break it into factors that you know the square root of. And so we have an odd number of zeros there, so let's find a factor, the largest one that we can, that has an even number of zeros, and that would be 100. Square root of 100 times the square root of 10. 100 times 10 equals 1,000, right? And so then we would just say square root of 100 is 10 times the square root of 10. That would be the simplification of the square root of 1,000. Let's do some practice problems. Look at practice problem E. Simplify that. The square root of 30,000. Well, the first thing you want to do on a big number like that is count your zeros. You have 1, 2, 3, 4. So that means you could use 10,000 as a factor here. and you could simplify it. Because when you have an even number of zeros, you can just simplify those. You know you can by the rules that we just did and the pattern we developed over on the left. So we'd have the square root of 10,000 times the square root of 3. Square root of 10,000 would just be 100 times the square root of 3. Let's do another one. Simplify the square root of 5,000. Well, you have an odd number of zeros there, so factor out 100 because you know what the square root of 100 is. And so you can have the square root of 100 times the square root of 50. And so you know what the square root of 100 is. That's 10 times the square root of 50. Now think, though, always think and make sure that you have simplified them as far as you can. Can you simplify the square root of 50? Yes, you can, because you can break that into 25 times 2. So just keep going. 10 times the square root of 25 times the square root of 2. And so that would be 10 times 5 times the square root of 2, or 50 times the square root of 2. So that's what the square root of 5,000 simplifies to, is 50 times the square root of 2. So on these large square root problems, sometimes you'll have to simplify a little bit more, maybe take a couple of steps in your simplification. But always, whenever you do a simplification of a problem like this, make sure that you've simplified it as far as you can. Make sure that you, under your radical sign, that's the most simplified form of that radical expression that you can get. Let's do one more. Figure out what the square root of 17 million is. Well, the first thing you want to do is count your zeros. You have 6 zeros, so you have an even number of zeros, so you can factor that out. And so that would be the square root of 1 million times the square root of 17. And so that would just be 1,000 times the square root of 17. That would be the simplified form of the square root of 17 million. Okay, well that's all for lesson 66.